Hello, ladies and gentlemen. Welcome to Math 30-2, Midterm Review, Part 3A, Chapter 3, Probability. Now, question number 10. 6 students are running for student council president. Each student is equally likely to win the election. What's the probability that Sonia will finish in the top 3 on election day? Well, this is straightforward. If you think about it a little bit, probability, Sonia's in top 3. Well, since in the top 3 means order's not important, so that's a 3C3. But how many ways are there in total? There's 6 students to choose the top 3. Remember, probability is what you want against the total, over the total. So 3C3 is 1, 6C3 is 20, so 1 in 20, and I'm happy with that. If one of those is 0.05, that's what Mr. Calculator says, I'm fine with that. And as I talked about before, divide by 100 to get percent, so 5%. All right, remember this is what you want versus total outcomes. So moving on. In the game of bridge, 4 players are dealt 13 cards with a stacked deck of 52 playing cards. Determine the probability that a player is dealt all the hearts. Well, probability all hearts. Well, what do you want? You want all the hearts. And how many hearts are there? There's 13. So 13 hearts, and you're choosing all 13. Now remember, there's 52 cards in the deck, and you're choosing 13 of those. Now, I will point out, sometimes numbers get huge here. For example, this is one way to get all 13 cards, but it's something like 6.35 times 10 to the 11 ways to get 13 cards from a deck of cards. And I'm going, it's like, wow. That's such a small percentage. You can see why sometimes I'll write the answer like this. I expect you to know it, rather than try to write out that decimal. Okay? Now, same idea, dealing all the kings. Well, think about it. Do not be like that. Do not be like that. People are watching. Probability for kings. So, that's 4 kings. Now remember, since it's 13 cards in total, you got some other cards. There's 48 cards left, and you're choosing 9 of them. 9 and 4 is 13. This is what you want, divided by your total, which is 52C13. Now, when I did this math, I got 16771066640 over 6.35 times 10 to the 11. That's a horrible number, but you can plug it into Mr. Calculator. 0.00264. Divide that by 100, you get 0.26%. Okay. So I might make you go to 2 decimal places on the percentage, just to be careful. Yes, if you said 0.3, I would accept it because I know that only make you go to 1 decimal place. Okay. So sometimes the numbers are just horrible but doable. Okay? Good. Now, Enzo rolls 2 standard dice. Determine the probability of each event. The sum is a 3 or a 12. Okay, when you roll the dice, what do you get? Well, what are your options? Die 1 will be 1, 2, 3, 4, 5, 6. Die 2 will be 1, 2, 3, 4, 5, 6. Now what I'm doing here is writing out the sample space, that is the possible outcomes. Do I want to do it? No. Do I have to because I need the numbers? Yeah. I got to see what the outcomes are. Now, some of you youngins might be able to do this. You have good luck. I can't. Please don't try. Now, it says sum. So add it together. This is 1, this one's 2, 1 plus 2 is 3, 1 plus 2 is 4, 4 is 5, 1 plus 5 is 6, 1 plus 6 is 7. All right, now, I'm going to pause the recording because I don't think you'd want to sit here and watch me do all these numbers. When you've got it filled in, come back and we'll compare answers, okay? So come on, pause the recording. Fill in the table. Then come back and we'll talk. Okay. So once you do this, I got this table. Notice the symmetry in 09. Oh, I did make a mistake. Never mind. Right. Sorry about that, guys. What did I say about dumb mistakes? Yeah. Brain hurt. Sorry about that. 5 and 1 is 6, not 5. 7. Never mind. Never mind. Getting old. Anyway. So I think it's correct now, so you can stop yelling at the screen. So the question is, the sum is a 3 or 12. Where's the sum of 3? Here and here. Where's it a 12? Here. So, how many times? Probability 3 or 12. Well, how many times do we want it? Did we get the outcome we want? 3. But how many outcomes are there? 1, 2, 3, 4, 5, 6. 36. 6 times 6 is 36. So that's 112. And I'm happy with that, but somebody's going to go 0.03 or 8.3% or something like that. All right. Now, you need to write out the outcomes for these. I need something because it gets confusing. Particularly when we get to the next question. Sorry, sum is odd or the sum is greater than 7. So how many odd numbers do we have? I go back here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18 odd numbers. So that is probability odd or greater than 7. So that's probability of odd plus probability greater than 7. Now that was, we just said 18, 36. Now, probability greater than 7 is greater than 7 is, oh come on, 1, 2, 4, 5, 6, 7, 8, 9, 10. Sorry, no, that's okay. That's not counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15. So probability greater than 7 is 15 out of 36. But the problem, we have overlap. They're not mutually exclusive. Probability intersection. No. Intersection. So how many are both odd and greater than 7? How many have we counted twice? Well, let's go back here. That's 1 is odd greater than 7. 2, 3, 4, 5. So we're counting 6 of them twice. So if I did this as a Venn diagram, this is the overlap to both. I got to subtract those because I'm counting them twice. So that is 18 plus 15 minus 6. That's 27 over 36. Now, I happen to know. Actually, I'm going to give you a minute to double check the math because it's a little confusing. Divided by 36 is yes. 4, 0, 5, which is 75% chance. So it's a 75% chance the number is odd, or the sum is odd or greater than 7. Okay. Now, question C. The sum is even given that the first die is a 1. So this is a restriction. So the first die is a 1. So these are results here. We have a 1. Then how many results we have that are even? We have 2, 4, 6. We have 3 results that are even and 3 that are odd. So probability even, given the first die is 1, well, there's 3 outcomes we want at a possible 6, which is 1/2, which is 5, which is 50%. Right? That's how that goes. Oh, running out of time? All right, my apologies, we're going over time, so I'm going to stop now. We'll finish this question in the next part of the video. Any questions, shoot me an email, otherwise, good luck.